Section 10.7, plane curves and parametric equations. This is a definition here, 3 definitions actually. It says let x equal ft and y equal gt, where f and g are 2 functions whose common domain is some interval I. The collection of points defined by x and y are equal to ft and gt is called a plane curve. So this is a plane curve right here. The equation x equals ft and y equals gt, where t is an I, are called parametric equations. So together it's a plane curve. Individually, they're parametric equations of the curve. The variable t is called a parameter. So we're going to graph one of these parametric equations right now. This will give you a better idea of how all this works. All right, so here it is. So this one says graph the curve whose parametric equation are given and show its orientation. And it says find the rectangular equation of the curve. So not only are we going to have to deal with this x and y as functions of t, but we're actually going to have to graph it, and then on top of that, we're going to have to turn it into an equation that contains only x's and y's. And that's what the rectangular equation means. So let's get started. First, we're going to have to graph this thing. So in order to graph this, we're going to have to set up a XY table. Do you guys remember those? Anytime I don't understand a graph, I can always use an XY table. So that's what we're going to do first. So here's our XY table. So for instance, our t is from -10 to 10. So we can start at -10. And then let's see what we get. Now I'm plugging the first one so you guys can see what that looks like. So that's going to be x equals -10 squared. So that's going to end up being 100. And then my y is going to be 2 times -10. So that's going to equal -20. So my x is 100. And my y is -20. So there's my first one. So I'm just going to continue with this process and kind of get a half of a table here, because this will be 10 of them here, and then I'll just try to create another one so we can get more of these values. And I'm just going to keep going. So I'm going to actually get 20 values this way. So here's all the values. Now, I don't think you need all of these values here, but you'll need a few at least to kind of see what's going on. Honestly, you could probably get away with maybe this one here, the 100, and then maybe go halfway at 5, maybe the 25, -5 there, and then go to 0, and then maybe 5, and then maybe 10. Maybe those would probably be enough values to really see what's going on here. But you wouldn't necessarily need all of those values, but I just put them all in there for your sake. Now I'm just going to plot those 5, and let's see what we end up with here. So there are those 5 dots that are graphed on the right there. And if you notice, I labeled them also, because we have to understand the direction also of our path. Not just the graph itself, but also the orientation. And that's why in the beginning it says the orientation. And if you notice, if we graph this, we started with A, and that's at -10, which is where we're supposed to start at, and we end at +10, which is here. So if we continue our path, then that means I'm going to start from A, which is down here, and I'm going to take it around, and then I'm going to go to here, and then I'm going to take it around the rest of the way and finish it this way. All right, now we stop and end there because of our parameters for t. It's set from -10 to 10, so there's no arrows there. It's just these dots. And then we also now have a direction, and our direction is in this direction, and that's actually the orientation. So when it says graph the curve whose parametric equations are given and show its orientation, these little arrows here are the way we actually show that orientation. Now I don't need the A, B, C, and D on there, and E, and I just put that under so you can see how this is actually being mapped. So now what we're going to do is we're going to find the rectangular equation of the curve. So we know x equals t squared and y equals 2t. So in essence, what I do is I just take one of the equations and solve it for t. So I look at the second equation, the y equals 2t, and I can solve this one for t very quickly. So then I just divide by 2. So t equals y over 2. So all I have to do now is just plug that in to the other equation. So I have x equals, and then I have a parenthesis here because I got to plug in for t now. And that's y over 2, whoops, squared. So I just plugged it in for t. And then when I actually square that, I get x equals y squared over 4. So this here is my equation for that part 2. So these are actually pretty quick to do. Again, like I said, I just take one of my equations, solve it for the variable t, and then I just plug it in the other equation. And that's how I get my equations.